I'm Paul Larson.
I'm Jerry Liang.
And I'm Scott Miller. This is our senior design presentation for an automated home lighting system. The basic gist of this is to replace a standard home lighting system with LEDs that are customizable, cost efficient and energy efficient. So it definitely needs to be affordable. Say right now we're looking around $15 to $20 per module. We want the modules to be replaceable. We can take them out, put them in. Easily installable, whether it is the modules themselves should be able to be installed easily by the customer, and the whole system itself, we have two options: either to have it professionally installed or to have intense installation manual for the customer to use.
And here we have some requirements that the customer has come up with, and we have used engineering design requirements to satisfy those needs. So the first one we have, system is programmable, and our engineering requirement is has memory to hold at least 3 safe settings.
Another one would be suitable for home use or commercialization, and the engineering requirement would be light can be distributed throughout an average sized home around 2,700 square feet.
Then the next one we have, which also is relevant to the home use one, would be system can support up to 100 light modules.
And the next one, customer requirement would be system is cheap, and the engineering requirement would be price of each light module will be less than or equal to $15. So this is our top level system diagram for the automated home lighting system. We have 3 inputs and 1 output. So for the environmental input, this is pretty much temperature inside the home. For user input, this is keyboard, mouse from the GUI. For power, we got 120 volts AC coming from the standard home, US, not European. And then for environmental out, we're looking at heat dissipation and light.
So if you look into the black box a little bit more, this is our PC/master control block diagram. We have the environment in, which is actually going to apply to all of these blocks, and that's like your standard in-home heat elements. So we have the user input, like before, is the keyboard, mouse. That goes into a PC, which is interfaced with the GUI for the customer for easy control. And then this code block goes for that GUI. It's going to be written in C#. And then from the PC, we go over to the master controller, which is a microcontroller, through USB. So that's what this USB line is for. We also have a power supply block, which is pretty much going to run off of AC power out of the wall. And that's going to power various things, in this case the microcontroller or the master control, and also buffers that are needed for the I2C line. So this one takes in your standard 120 volt AC, 60 hertz, outputs 12 volt DC. The master controller has master controller code written for in C, which will be programmed on there. And then over here, the master controller will take whatever data is received from the user and push it out with I2C. And those will usually go through buffers, and the buffer will pretty much just make it so the signal can make it over longer distances. So the buffer's input and output are going to be the exact same, which is the data that we're pushing out to the other controllers. And we have a master control enclosure. This is more of a mechanical thing. It's the physical box that's going to be holding the master controller.
And now I'm going to talk about the slave module. We're going to get I2C signal coming from the master module going to a slave controller, which will be an Atmel microcontroller. And we're going to need slave code to properly interpret the I2C signal into the proper control signal for our LED driver. Our LED driver is going to take that control signal and basically amplify it into usable power signal for our optics. Our optics can include LEDs, which will give out heat and light as we come out. So light will be the one part of the environment out, and the heat will actually go into our next block, which would be thermal heat sinks. Our heat sink is going to be enclosed in our slave enclosure, and then Lastly, we have the track system, which would be part of our whole overall slave module. And also we have a power supply block, which will supply power, 12 volt DC to our LED driver and our slave controller. Finally, we have an environmental in, which will be the heat that will be part of the whole slave module.
So this is our estimated project timeline. We hope to make progress on something about every 2 weeks, and this is completion. So by week 12, we hope to have a complete schematic capture of the entire project, of all the blocks and everything. By week 14, we hope to have the PCB designed so we can have them shipped out and made and shipped back to us. We hoped by week 16 to have the GUI completely written, so working and able to send the data back and forth. We plan by week 18 to have all of our testing done. Do know though that testing will be done throughout, like as we get things in. We just hope to have it all tested and we're confident on it. And then by week 20 we hope to have a completely put together prototype for display at the Engineering Expo. So for our control protocol, we decided to go with I2C. There's multiple reasons for this. One, it's fairly easy to figure out. The code out there already exists. It's a pretty standard protocol. And two, it just kind of naturally fits with our project. So basically you have your master, which controls your clock and sends and requests data. And you have slaves where you can hook up to as many as you want, depending on how many address bytes you support. And there can be either 7 or 10 bytes for a total number of addresses. So basically, if the master wants to say, for our system, this would be the master controller, these would be the individual light modules that are controlled from the computer, which is the slave. It basically will send out a start bit, and that start bit, all these will be listening for that, and as soon as they see that start bit, they'll listen on the line. And then the master will push out an address. So they'll all listen, and then when that address gets pushed out, if the address matches on the slave, it continues to receive data. If it doesn't, it just shuts off and stops listening. And that's kind of how you can control each light individually. Once it has the proper address, it'll send the data or whatnot, so fading lights, changing intensity, flashing, or whatever you want. And then there's also ACK bits that tell the master that they got that information.
Okay, so one of the things we want to talk about here is how we're going to have our LEDs replace our incandescent bulb, but at the same time maintaining that light sensitivity and light intensity that we're going to get. Because LEDs actually do not have a standardized test for those, we will have to make our own test. So what we're going to do is we're going to limit our LED to a 30-degree angle, and we're going to have a photoresistor measured 1 meter directly below it away. At the same time, we also have an incandescent bulb measured also 1 meter away. That way we can directly measure to see which one has a higher resistance or lower resistance, and that way we can have a comparison between the two to tell whether or not our LED will be capable of having something that has as much intensity as the incandescent bulb.
Alright, so this is an example of, just a basic example of our interface. We have light intensity adjustability, how bright the LEDs will go. Obviously color sliders, to change the different red, green, and blue colors. Here's the output. It's going to actually show kind of what each module is doing. What color is going to output and stuff like that. We're going to have a timer. We'll have a duration. How long will this go for? Or we'll have during what times will this turn on. We also have some at least 3 customizable presets. You can describe what it is here, saying this is mood lighting, and you can have all these set just by checking this box. Also, obviously we need to assign which module does what, so there's going to be a lot of customer interface in the GUI itself. This is where most all the the customer is gonna be manipulating the lights.